Yes, sir, it is already filled with 100 members already. So those who are not available, they can go with the video streaming sent for you. Okay, so you can share with everyone to go with the video streaming. And if you still have any doubt, you can text me to the same WhatsApp number. Okay, through WhatsApp. If you have any doubt during the class or if any. Okay. So during the class, if you have any doubt and you are watching the streaming of YouTube, you can text me to my WhatsApp number. I will be able to respond immediately. Okay. Otherwise, if you have any doubts, again, you can still stop the class and you can ask for any doubts if any. Okay. Shall we start then? Yes. Yes. Am I audible again?
Sir, please go ahead.
Yes, Anubhav, that's what I told. You can join with the YouTube link and have.
Anubhav, I have sent the YouTube link. You can just forward in your group. Anyone who can't get into this session, just go to that YouTube link and you can have the live streaming of the same.
And when you are on the YouTube link, and if you still have any doubt, you can text me to my WhatsApp number. So I will be able to respond immediately. Okay.
ಸರ್ ನಿಮ್ದು ಹಂಗೆ ನಂಬರ್ ಶೇರ್ ಮಾಡ್ಬಿಡಿ ಅಲ್ಲಿ ಮೆಸೇಜ್ ಇದರಲ್ಲಿ.
Okay.
ಅನುಭವ್ ನಂಬರ್ ಇದೆ ಅಲ್ವಾ?
ಅನುಭವ್ ಹತ್ರ ಇದೆ ನನ್ನ ನಂಬರ್.
ಅವ್ರ ಅನುಭವ್ ಯು ಕ್ಯಾನ್ ಶೇರ್ ಅಲೆ ಸರ್ ನಂಬರ್ ಆಲ್ಸೋ. Sir, I will be online only.
Okay.
Parallelly, I'll be with MTech students also. Okay.
Okay. Yes, Anubhav, are you on the line? Anubhav?
I think Anubhav has not yet joined, I think.
Okay. Anyone from the B division? Any student from the B division?
Anyone, I will send the YouTube link to a couple of other students, sir.
Yes, sir.
Then forward.
Yeah. Yeah, since it is YouTube streaming, no need to do the recording, no, sir?
ಮಾಡ್ಬೋದು, ಅಲ್ಲ ನೀವು ಮಾಡ್ಕೊಂಬಿಡಿ ಅಷ್ಟೇ. ಬೇಕಿದ್ರೆ ಆಮೇಲೆ ಬೇಕಾದ್ರೆ ಅವರಿಗೆ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಹಾಕೋಣ ಬೇಕಾದ್ರೆ. If someone wants once again, you can record, no, sir?
Yes.
Yeah, you can record.
Yeah, but there is some problem with the audio since I'm using both mobile as well as this one laptop.
Or anyhow, that YouTube thing will be there, right? Yes, so that can be, that link can be given.
Yes, thank you.
We won't make it public. We can just have that link and we can record it and give it to students. Not an issue.
Yes, coming to the class, I will be sharing my screen. And for your information, I haven't installed anything as of now. So it will be from the scratch again. Okay. So everyone is able to see the desktop, my desktop. Yeah, you should be able to respond me quickly through your mic only.
Yes, sir.
Yeah, fine. So this is the website what I am asking you to go through for the to use electric tool for your CMOS VLSI subject. Okay. So this is cmosedu.com. This link has been already shared. Okay. So here you have you are able to see this electric VLSI. There is a option called electric VLSI in here. So you just follow the instruction. Once you click on this electric VLSI, so you will come to the new page of the electric where you have all the necessary links or documents related to the lab, what you are supposed to do. Right? Yes, no, maybe. Everyone? Sir, ಅದು ಮ್ಯೂಟ್ ಮಾಡಿರಿ ಸರ್ ನಿಮ್ದು.
Yeah, one more. See,
yeah.
anyone has to respond to what sir asks immediately. Okay, so otherwise it will be a pause and it's a waste of time. If something is asked by sir, make sure that you people immediately respond. Okay. Okay, sir. I'll just mute now.
Yeah, fine. Yes, everyone. So I'll coming back to this tool. You see, this is the tool what I told. Go to the CMOS edu. I'm telling it once again, cmosedu.com. In this, there is an option called as electric VLSI. So this is the tool what I'm using as an open software, which is similar to that of Cadence, all the procedure. Okay. See, this is electric VLSI design system tool. Okay, so the first thing is you have to download this Java. The in the Cadence, what you invoke the tool is basically through CSH command, right, which invokes all the tool written using shell scripting. Like in the same way, this electric tool is actually written using Java file. Okay, usually this Java will be running at the back end for the every action that you perform using this tool. Okay, so first you have to download this Java. Okay, and you will get a this is your Java supporting file. Okay, and then this is the electric 9.07 version. Okay, 9.07 version. It is a jar file. Jar file means it is basically a kind of zip file. Okay, you cannot use it until unless you install this Java file. Note that. Is that clear? And another thing is you have to use LT Spice at the back end. It used to simulate using LT Spice. Hence, you have to install this LT Spice simulation tool also. Is that clear? Right? So in your folder, you should have Java supporting file, electric file, and LT Spice. Okay, LT Spice. And another important thing is it is c5 underscore models dot text. This is the another text files which you have to download and keep it yourself, because this itself will be acting as a technology file. Understood the point? Like you used to use 180 nanometer technology in your Cadence. So here it is C5 models is the technology file what you have to include here. Is that clear? So all those are available in this link itself, in this page itself. Okay. So what are the things that you have to install? You have to download Java file, supporting file, then electric tool, C5 models dot text file, and LT Spice. So these are the 4 things that you have to download. Okay, these are the 4 things that you have to download. Fine. So once you download, you have C5 models, electric file. Basically, this will look like a zip file. It is of no use until unless you install this Java file, and then LT Spice. Okay. So first you see, I will just install the Java file. So it takes some time. And parallelly, I am installing the LT Spice also. Both Java and LT Spice, you see the location C program file LTC LT Spice 4. Okay, these two files has to be installed. I should have installed this because for your understanding purpose, I am just doing it all the thing online. So make sure that you follow these procedures carefully. LT Spice is installed. So it is asking for the update. You just click no for the update, and you have successfully installed the Java files also. Okay. So this is LT Spice, and the Java is also done. So no need to go for. Okay, it is not yet installed. Yeah. Yes. Everyone is clear up till here? Everyone? I have installed the Java file and LT Spice file. That's it. And no additional Java thing has to be installed. Only thing, when you are, once you download all the thing, you just come out of the network. I mean, stop using the network, and you can use it as an offline also. Okay. This Java file. No need to do install additional add-on for Java, because as you know, it will keep on asking for the additional add-on for the Java file. Is that clear? Everyone is clear up till here? Yes, if you respond immediately, it will be good. Yeah. Fine. Now you see, once I install the Java file, this electric 9.03, which used to look like a zip file, it is a kind of looking like a Java file right now. Understood? Is that clear with everyone? Okay. And note that, so all these things what I have downloaded, C5 models, electric 9.03, this is the older version what I'm using, but you can download the same. And Java file and LT Spice. So these should be kept in an electric folder with the name electric. You see here with the name electric, and it should be saved in a C drive. That is important. It should be saved in a C drive. Is that part clear? Electric folder in a C drive with your electric tool. LT Spice, that is important, and C5 model. C5 model, electric tool, and LT Spice and Java, all these things should be present in a same folder, single folder, and that folder should be named as electric. Okay, and then that electric folder should be present in the C drive. You see here, it should be present in the C drive. Is that part clear with everyone?
Yes, sir.
Yeah, now I will start working on it. Okay, so like I will double click on this. Now it is entirely GUI now. Okay, it is entirely GUI, but at the back end, for every action that you do, there will be a Java file running behind this. Okay, so I will just double click on this electric 9.03. When I click on this, you will get the tool like you used to get in your Cadence when you run the command virtuoso ampersand. Okay, virtuoso ampersand, and you see this is your virtuoso command interrupt window, and this is your the field or the window where you work with your schematic and layout. Is that clear, everyone? So here they are not running any command. Basically, you are just it is now onwards. It is completely GUI, not command oriented. Double click on the electric tool, and you will get this window. Okay. This is your schematic or layout window, and this is your virtuoso window or the command interrupt window. As I told, for every action what you do here, there will be a command running at the back end, and you can see those command here in the command interrupt window. Okay, and here on the left side you see there are three options called as component, explore, and layers. Okay. Layers are nothing but the technology files what you have come across. So you are not using much about this layer, but you will be using more about this explore and component. Okay. So here explore, you see here, here it is no name library, means it has a library which is already with the name no name. I will just rename it. Okay. Rename the library. I am renaming it as, okay, I will just create a new library so that you can understand. Okay, new library. So the new library name will be test. Okay, so this is the test what you see, and this no name, I will just delete this library or close that library. So this is the new library what I have created. Okay, and in the same what you see here, this will be saved as test.jelib. You see here, it will be saved as test.jelib. JELIB means Java Electric Library, means basically saved as a Java file which runs at the back end. Okay, and again, as I told, there are many tools involved in this, that is particularly for the schematic, for the layout. There are different tools again, and all these are written using Java file itself only. That's why it is saved as an extension JELIB. Okay, for library I am telling, for library. Is that clear? So I will save this library first. Initially what I have done is I have created the library. Okay, I have created the library with the name test, and then I have saved. I again saved it with the icon here, save library, and when I click on this you will get a new window where it is to be saved, and you see that is saved in a same electric folder where you have invoked the tool, where you have opened the tool using double clicking the tool icon. Okay, so you see here the test.jelib is present in the same folder. So this is about creating the library. So you can create a new cell. So that is library. Don't get confused with the library name and cell name. So inside the library, I am creating a new cell, and in the cell, I will create a schematic one. First, I will start with the schematic, and of course, inverter again. Okay. So inverter, schematic, click OK. You see this is the library, and when I open this there is a plus icon over here which makes you to look like a drop down or a hierarchy window. So now I see this is inverter.sch. Okay, sch means it is a schematic format. It will be saved in a schematic format. So when I click on this, I will be in a schematic window, and when you see the corresponding components here, you see you will be having a schematic components over here. I will make the window color scheme as white background. I hope now it is able to see it properly, right? Is it clear with everyone up till here? Any doubt?
No, sir.
Yeah. So if you have any doubt, I will just create another cell. Okay. So I will create another cell. You see, I am creating another cell, new cell. Well, I will give the same name, inverter itself, INV. I am giving the same name, but I will select layout now. Is that clear? I will select layout and I will click OK. And you see here with the same name, I have two types. I have two types. What are those? Schematic and layout. So when you double click on schematic, you have a schematic window and you have a schematic component. Come back to the Explorer. When you double click on the layout, you will be having a layout window here and you will be having a layout components over here. Okay, layout components over here. Fine. So I will start with the schematic now. Any doubt up till here? I have repeated it once again, creating a cell. I will start with doing a schematic now. Any doubt up till here?
No, sir.
Yeah. Yeah. I'm in a schematic. I will double click on this. I will be having a schematic window over here. And I will, when I come to the components, I will be having a schematic components. Okay. So here I will be selecting components, and look at here. I should be selecting 4 terminal components. So this is 3 terminal, this is 3 terminal, and this is 3 terminal, and this is 4 terminal. You see. Okay, so when you, there is an arrow mark with the black arrow at the bottom, which looks like a drop down window. Okay, so here you have 3 terminal. When you click on this drop down window, you will get all the components which are basically 3 terminals. Okay, so there is another icon at the below this. What it is actually 4 terminal component. And when I click on this arrow, which is basically a drop down kind of, so when I click on here, I will select any device. So you will get a 4 terminal component. Is that clear with everyone? Yes.
Yes, sir.
So here you should be working on 4 terminal components, not on 3 terminal components. Okay. So basically you should be working on 4 terminal components. I'll repeat it once again. I will select the 4 terminal icon with a black arrow at the bottom, which gives you a drop down kind of window. So you have all these components which are basically 4 terminal. So you are using NMOS and PMOS over here. So this is NMOS at the bottom and another drop down and PMOS at the top. Okay, is that clear? I have PMOS and NMOS. So everyone is able to see the components over here, PMOS and NMOS. Is it clear with everyone? Yes, no, maybe.
Yes, sir.
Yeah. So now this is pin. So I'm able to move it with a large distance, not with the small distance. That is because of the grid problem. What you see here, you have a largest grid as of now. So I will reduce it so that I will be able to move it with the small unit as well. Okay, so this is the pin what I am selecting here. Fine. So this is input pin, this is output pin, this is VSS pin, and this is VDD pin. You see here you have a pin. Okay, I'm selecting it. So you can look at the property of this. Okay. So to make the connection, note that carefully. To make the connection, left click at the starting point, right click at the end point, another right click at the end point, and right click at the end point. 10:30. Yes, did you understood how the connections are made? Tell me. Left click of the mouse button at the starting point, right click at the mouse button at the end point. Is that clear, everyone? Any doubt? You should be able to respond immediately.
Oh,
Am I audible with everyone?
yes, sir.
1 second. Yes, am I audible? Yeah.
Yes, sir.
Yes, sir, audible.
How is the connection? Yes, to rotate this, select this, go to edit, and you have an option called rotate 90-degree clockwise. You see, you can make a small movement. And to make the connection, left click at the starting point, right click at the end point. This rotate counterclockwise. Left click at the starting point, right click at the end point. See? Left click at the starting point, right click at the end point. Left click of the mouse at the starting point, right click at the end point. Is that clear? Is that clear with everyone?
Yes, sir.
And the body terminal also. Look at the body terminal, fourth terminal. Left click and right click at the point where you need curve. Right click at the point where you need curve and right click at the end point. Understood? I will repeat it. Left click at the starting point, right click wherever you need curve, right click wherever you need curve, and again right click where you want to end the connection, starting point connection and the end point connection. Okay, so this is your schematic and the pins along with the pins. Note that the pin is not completely set up. Okay, note that the pin is not completely set up. You have to export this pin. I will select the pin. Note that you have to export this pin as an input output separately. Okay, so select this input pin, go to export here, create export. Look at the option over here. To export the pin, select the pin, create export. Export, go to export, create export, and the bind key is Control E. If you can look, it is Control E. Okay. Once I click on this create export, I will get a window, new window, where I will give an export name as VIN, and characteristics. Export characteristics are input. You see, this is an input pin. Okay. Similarly, for the output pin, I will select the pin, export, create export, V out, and it is output pin. Note that. Okay. And for VDD and VSS, select the pin, export, create export. This is VDD, and this is power pin. Okay, this is for power connection. You have to define it as a power connection for VDD and VSS. Is that clear? VDD, and this is VSS. Go to export, create export. This is VSS power. Is that clear? Any doubt? Any doubt?
No, sir.
Yes, no, maybe. You should repeat it immediately. Shall I continue?
Yes, sir, you can continue.
Shall I continue it further? Okay.
Yes, sir.
Yeah. So before I do the simulation, as I told, the size of the transistor, you should make it proper. That is, the width of the PMOS should be made twice. Okay. I will select this and go to cell properties. Cell properties. Okay. Otherwise, double click on this. You will get width. I will make it as 20. Length, it will be 2. Okay. And double click on the NMOS. Width, I will make it as 10. The length will be 2. Okay. The length will be 2, but it doesn't mean that it is a 2 micrometer. I will mention it further because we have certain settings to be done. Okay. So this is how I just changing the transistor properties. Click on this, double click on this. Is that clear? Yes, no, maybe, quickly.
Yes, sir.
Yes, are you people listening?
Yes, sir.
Yes, sir.
Srimad, Akhil, Nitin?
Yes, sir.
Okay.
Yes, sir.
So the next is important step. You see here, I need to create export for this PMOS and NMOS also. To do that, note that you need to look at these procedure carefully. Select on this, select on the transistor, go to tools, simulation spice, set spice model. Okay. Since as I told, at the back end, it used to run using spice simulation. You need to set a spice model for this. Okay. So once I click on this, a spice model is set. I'll just drag it outside and I will double click on this. Double click on this. I will change it as a PMOS. PMOS. It is a PMOS. PMOS device. This I have set spice model as PMOS. Similarly, for the NMOS, select the transistor, go to tools, simulation spice, set spice model. Okay, so this is how you set the spice model for the MOS devices. Select on set spice model. I will just drag it, double click on this, and I will rename it as NMOS. Okay, so this is NMOS device and this is PMOS device. See, I have not given this as a name. It is actually setting up the spice model. Is that clear with everyone? Everyone up till here?
Yes, sir.
Yes?
Yes, sir.
Everyone, is that clear up till here?
Yes, sir, clear.
Okay. Shall I continue further? If you want me to repeat, you can ask me to repeat. I will just repeat the procedure by deleting whatever I have done so far. Okay. Anyhow, you can go through the video, which I will share it with you, and it is also streaming in a YouTube. we can follow the same. Okay. And now, before I start the simulation, I need to do certain setup to these tool. Okay. And that is preferably at the preference. I need to do certain setup at the preference. Look at the preference here. And there is another icon called as preference overlay also here. Okay. So in the preference, when I click on this preference, I will get certain this one. Okay, things to set up. So you are creating in a C drive / electric tool. Okay, so all the simulations will be run there itself only. Fine. And you have, I will share the videos in the same. You can look through the videos for the procedure what I have done. So this is the schematic what I have shared so far, and this is the layout which you can do it further. And to continue the same, to understand or to go through the same which I have told you, you have tutorials and videos illustrating the use of electric that you observe here. Okay, tutorials and videos. You can click here and you will come to the another window where you have a video lectures on the tutorials. This link is also shared with everyone. Okay, this link is also shared with everyone. I will just repeat some of the video to set up. Yeah, so this setup we need to look up. I'll just repeat it. So maximum memory 512, maximum permanent space 128. So maximum memory 512, maximum permanent space 128. This is the space that you are allocating. Okay, in the general settings. And then you have to go to the technology. Okay, this is in the general, and then you have to go to the technology. In this again, go to the technology. You have to select. There are particular devices what you are using. You have to select it as CMOS. Okay, and okay. So 6 layers. I just limit it only up to 3 layers. And layout to technology, what you are using is CMOS. Okay, and I will select analog. These settings you have to do it only for the first time when you are doing it. Okay, these settings you have to do it for the first time. And next scale, you see you have to select MOCMOS and 200 nanometer. MOCMOS 200 nanometer. I will select it. MOCMOS 200 nanometer. This is what selected. So now your technology what is 200 nanometer multiplied by 2. Okay, so it is 400 nanometer. 400 nanometer will be your technology, or zero 0.4 micrometer technology is what you are working. So in the scale, you have to select MOCMOS because we will be dealing with these MOCMOS 200 nanometer always. And then you can change it here. You see here, you can change it here. Can change the technology here. So this I will change it to 300 nanometer. So 300 nano into 2, it is 600 nanometer. Basically now it is working with 0.6 micrometer technology. Okay, 300 nanometer, 0.6 micrometer technology. Okay. and next mark for all library. So before this, okay. So this is one of the setting, and then general is general. Tools, and in the tools, you have to go to Spice CDL. This is because your backend you are running with the Spice CDL. So I have to select Spice 3 and level 3, Spice level 3. Okay, note these important setup. Okay, and after writing run ignore output, run ignore output. Okay, so run program. Now what you are defining, you are basically making this entire cell as a variable now. Okay, and that value of that is assigned to certain variable that you are going to define here. In the run program at the backend, it used to run using LT spice. Okay, that's why I need to look at the location where my LT spice is stored. Electric program files, LTC, LT spice, C, SCAD3. See, I will just copy this location. I will just copy this location, LT spice 4, C, backslash SCAD3. SCAD3 small case SCAD3 dot exe, that is an exe file. So run program is basically an LT spice. You are running using this LT spice SCAD3 dot exe file that has to be given here. Okay, and the arguments what you're going to define here is argument what you're going to define here is this one. I will just highlight it so that you should be able to see it properly. Okay, so the argument what I'm loading there is are you able to see this? The first line hyphen I. I'll just read out, you can note down the same. Hyphen I space dollar flower bracket file name, that is in capital letter, close the flower bracket, again space hyphen small r space dollar flower bracket file name underscore no underscore ext flower, close the flower bracket, and dot raw. So this is again hyphen r small r space dollar flower bracket file name underscore no underscore ext, close the flower bracket, and out. So this is the argument what you are loading here. Okay, I will share this, and this is the location of that SCAD3 LT spice. I will share this later on, you can go through the same. So this is present in this link where you are supposed to use is given in this file itself. Okay, you can follow the procedure by following the instructions in the video lecture. Okay, so these are the settings that has to be done in the preference. Once you do all these settings, okay, what are the settings? First, at the general, setting up the maximum undo history, maximum memory 512, maximum permanent space 128, and then in the tools, spice serial, spice 3, and here run ignore output. For every simulation it will run, and it will ignore the previous simulation run. Okay, and this is run program is backend run through the LT spice. You need to load the location of that LT spice, particularly scad3.exe, and this argument which you are defining it as a variable, where for every execution the cell that you have created, that is, it might be schematic cell or layout cell, so that will be assigned to this variable or this argument. So it will create that raw file, that means the netlist or the schematic, and again it will give the output file in the sense of it might be in the graph or tool, electric tool graph, like that. Okay, and then at the technology, you use the technology CMOS technology. In the CMOS technology, you are changing it as a 300 nanometer. 300 nanometer multiplied by your length will be your actual technology. Okay, so your width will be 300 nanometer into 10, 300 nanometer into 20 for the PMOS, the width I am telling. For length, I will, for the length it is 2 over here, you can check it. So the length is 300 nanometer into 2, it is 600 nanometer or 0.6 micrometer technology. Is that clear? Once you set up these preferences, you can click OK, which will be marked for all the libraries. Come back to the schematic now. Okay, and now this you're going to save. Is that clear? And now to run a DRC check hierarchy. Check hierarchy means like you used to do check and save in the case of Cadence, like it is check hierarchy in the case of electric tool. The bind key is F5. So when you do this check hierarchy, it is the same kind of check and save in the case of Cadence. It will check all the components and its connection, whether all the terminals are connected properly or not. That's it. Okay. I will click on this check hierarchy and come back to this window, and you see there are 0 errors and 0 warnings. Okay, so I will delete this connection, and again I will do the check hierarchy. You see what happens. DRC check hierarchy. See, there are 1 errors found. To look at the errors, where you have to go? You have to go to the Explorer window only. Explorer window. So this is what you need to open, and there is an arc dangle. That means some incorrection in the arc. When you double click on this, it will show this is hanging. Okay, you need to complete this. Okay, now how to do the correction? Left click on the starting point, right click on the end point. So once you can do, again check and save, and you look at here, there are 0 errors and 0 warning. So this previous errors you can delete it. Now you can do it once again. Check hierarchy, you see there are no errors in here. Is that clear, everyone? Up till here? Yes, no, maybe.
Yes, sir.
Srimad.
Yes, sir.
Kaushik. Nitin.
Yes, sir.
Pooja.
Yes, sir.
Anubhav.
Yes, sir.
Are you there or not, everyone?
Yes, sir.
So I will just show the simulation, how to do the simulation, and I will just wind off. Okay. So to do the simulation, you have to write the spice code for the same. As I told, this has to be run through Spice code. At the back end, it will run through LT Spice. To run this, to do the simulation, I will have to write the Spice code. To write the Spice code, I will go to component and I will go to miscellaneous and I will just go to Spice code here. Okay, where in the components miscellaneous Spice code, I will get a certain text over here. Okay, I have a manual for the same. I'll just go to the code that has been written and I will explain the same for you. You see, this is the manual. See, this is the Spice code. Okay, I will explain the Spice code and later on I will write. See, this is, I am including that C5 models.txt file, the technology file. Okay, how will I include? Dot include the location of that. As I told, it will be present in the C drive with the folder name electric. So that file C5 underscore models.txt will be included. And then I am defining VDD, VSS, okay, and Vin I am defining it as a pulse. So whereas the first argument refers it is an initial delay, the second argument refers it is an higher voltage, the third argument lower voltage, and this is rise time, fall time. Okay, the third is fourth is rise time, fall time. The first is initial delay, second is higher voltage, the third is lower voltage. So the next two are rise time, fall time. This is on period, that is pulse width, and this is the total period, that is the total pulse period, and this is pulse width on period. That's it. First 10 nano, and second 20 nano is the total time period. Okay, and here I have done the DC analysis dot DC. I am varying this V in from 0 to 5 in terms of 1 millivolt. Okay, so I will just repeat the same here. Okay, select this text and Control I. Control I is the bind key to check the properties. Okay, here is what I need to write the Spice code. Select the multi-line. So dot include C colon backslash electric backslash capital C 5 underscore ELS models dot txt. Enter for next line. Next VDD, I am defining it from VDD to 0. VDD to 0 in terms of DC as a 5 volt. Similarly, VSS to 0 as a DC 0 volt. And next Vin from Vin to 0 as a pulse. The initial is 0 space 5 space 0, 1 nano rise time, 1 nano fall time, 10 nano on period, 20 nano off period. Okay, I will do the transient analysis. The command to run the transient analysis dot tran from 0 to, so since the end period is the one total period is 20 nano, I'll just take it as some 40 nano. I'll just look at two cycles, 2 pulse width. Okay, I'll click OK now. See, this is the code what has been written now. Okay, to do the simulation, go to Tools, Spice Deck, write Spice Deck. Okay, so this is the command to run the simulation. Go to Tools, Simulation Spice, write Spice Deck. Once I click on this, it will ask to save. This is the window. This is the window, the 2 windows what you will get to observe. Okay, see, this is the code what I have written. This is your output window which you will be able to see here, and as you see in the code, NMOS length is 0.6 micrometer. As I mentioned earlier, total 300 nanometer into 0.6. W is 300 nanometer into 10 is 3 micrometer. For PMOS, it is 2 times of that. 300 nanometer into 20. It is 300 nanometer into 20 is 6 micrometer. That is the width. You see, this is the technology, and this is the SPICE code to run the transient analysis. Okay. And to check the waveform, I will go to the visible traces here. Pick up visible traces. I'm selecting V in and Shift V out. For multiple selection, I'm using Shift. I have selected V in and V out. Once I click OK, you see, I will get 2 pulse width, 2 waveform. So here it is starting from 0, and to separate, I will add plot plane so that I will get another. So I will drag this win input to the upside. Okay, you see, this is your input, which is very smooth and defined according to your definition. Rise time 1 nanometer, on period 10 nanometer. So fall time 1 nanometer, which makes a total of 10 plus 2, 12 nanoseconds to nanoseconds. Rise time, fall time, like this. And correspondingly, you have, when the input is high, the output is low. Okay, so this is your transient analysis. Okay, similarly, to do the DC analysis, I can change in the code, or I can change here itself only in the code what is written here. Dot DC, I'm varying V in from 0 to 5 volts in terms of 1 milli. In terms of 1 milli, I will run the command here, run. You see, this is my input. I can merge it here. I can delete display, and this is your DC analysis. And you see, this is your point where your switching point is getting, that is approximately VDD by 2. So it is 4.71. I mean 2.471 is your switching point. 2.471 is your switching point. Okay, so this is how you do the transient analysis and DC analysis for the inverter circuit using electric 2. Any doubts so far? Yes, no, maybe. So this is what the actual simulation which is running at the back end. Again, this will be loaded in the electric tool. Once I close this, yeah, well, that is not opening in here. Yeah, that is what you can observe it in the there itself only in the LT Spice simulation window results. Yes, anything else? Any doubt? Any doubts so far?
Sir, can you once tell from where did you write the spice code after selecting the component?
Transaction. Yes, any doubt? Again,
Hello, sir. Is it audible?
Akshay, Anubhav.
Yes, sir.
Matsudan. Yes, what happened?
Yes, sir.
No. I was not able to hear actually. You can text it here. You can text it here in the meeting room itself. Okay, any doubt? Yes, you can text it here in the meeting room. Yeah, if you are offline and you are looking at the YouTube, I will not be able to see your messages because since you will not be in the meeting, but you can text me in the WhatsApp itself only. That's what I told earlier. Kaushik has written no doubt at now 10:30. I have not get any message afterwards. Yes, Srimad. Yes, at least now you should speak and tell me any doubt. Now I am able to hear to certain extent. Gokul, Gokul,
Sir,
what doubt do you have?
am I audible, sir?
Gokul, you are audible.
Sir, the spice code L ಬರದ್ರಿ sir, like first time.
Okay, I'll just repeat it. This is my solution window. Yeah. This is the code, okay? I will Yes, Gokul, am I audible now properly?
Yes, sir.
Am I audible properly?
Yes, sir.
Okay, one moment. Yes, Gokul. ಗೊತ್ತಾಯ್ತಾ?
Yes, sir. Got it.
Okay. So this is how you write the command. And to run, you need to save it first. And according to procedure, first check BRC. Make sure that there is no error. Here you get two windows. Understood, Gokul?
Yes, sir.
Yeah. Anyone else? Any doubt? Further, if any? So this is about only the so far you can complete with the schematic so far. Okay, and in the next coming instruction class, I will be starting with the part B. Okay, that is analog experiment. Common source, common drain, and common gate. I will explain the design of it and ask you to do it accordingly. Okay, but in the meantime, you can be able to finish the schematic of land, NOR, MUX, I mean transmission gate and MUX using transmission gate. You should be able to do all. Is there any doubt further? Gokul? Srimad?
No, sir. No doubts.
Okay.
Yes, sir.